Okay, so in line with the presentation's description, we'll start by setting up a Node.js server with Express and MongoDB for user data storage, and then React for the frontend that will interact with our backend to handle authentication. Alright, so let me show you our application at work. Here we have the sign up form where users can create a new account. The form asks for an email, a username, and a password. And once everything is filled out, you can click in the sign up button to submit the form and create your account. Now let's try signing up with a test email. You can write user test, username, user test, and password 3, 4, 5, 6. So once we have successfully authenticated, we are greeted with a simple welcome screen. This is because the primary focus of this application is the authentication process itself. This welcome screen confirms that the login process has worked correctly, showing that the user is recognized and authenticated. Let's refresh the page and it's still there, which means our credentials are correctly stored in the browser. Notice that there is a logout button displayed on the navigation bar, which also confirms that we are correctly authenticated. We also have this message in the console: user test provided a valid token, authentication completed. So now let's log out. User test, and the login was successful. And as I mentioned earlier, this application provides a solid foundation for building any type of app, since authentication is a crucial part of almost every application. So with this code as your base, you can easily expand it into, for example, online store, chat application, or any other kind of project. This authentication system is already in place, so you can focus on adding features, changing the design, and customize the functionality to suit your needs. Alright, so this is our server setup. This file is the main entry point for our login application. It's responsible for setting up the server, connecting to the database, and configuring necessary modules for handling authentication and requests. It begins by importing the necessary modules, including Express for building the server, Passport for authentication, Course for handling cross-origin requests, and it integrates JSON Web Token authentication via Passport, which is configured using a custom strategy in the auth module that is located in this folder, libs. And then the server is connected to a MongoDB database, as indicated by this require. Fork this file that is responsible for establishing a connection between the application and MongoDB database using Mongoose, very popular library for Node.js and MongoDB, which simplifies the interaction with MongoDB by offering a lot of tools to define models, query the database, and manage relationships between data. But this is about how to set up a Node project with MongoDB from scratch. If you want to dive deeper into this topic, I will leave you a link in the description about how to upload images with Cloudinary, where I go into more detail on the subject. Here I'm going to move faster in showing you how to build this application. And then we have the middleware configuration. This middleware express.json parse JSON requests and makes the data available in request.body. CORS enables CORS for all routes, allowing the API to be accessed by clients from different origins. And then we initialize passport for handling authentication. Next, we set up a route. It's the only route that we will need for this project. That is for handling user-related requests. And last, we set the port number on which the server will listen. And now let's move on to the models folder, where the user's file is located. And in a model in this kind of application, we define the structure and how we store the data in our database. A model is built upon a schema which defines the structure of the documents in a MongoDB collection. And the schema specifies the fields that each document will have. In this case, username, password, email, along with their data types, validation rules, and any default values. And what is what we are defining here? It's simply that we want that each user document will have a username, password, and email fields, all of which are strings. It's a way to interact with the MongoDB database. It allows you to perform operations such as creating new documents, insert data, finding documents, querying data, and updating documents, and deleting also documents. And now let's move on to the route file. And here is where we will handle the backend logic for user authentication. As you see here, we import the model to interact with the MongoDB database, and then we use various middleware such as Passport for authentication, bcrypt for passport hashing, and JSON Web Token for creating new JSON Web Token. However, first we import the Express framework, which provides us a set of features for creating and organizing our application. So by using Express, we are setting up the foundation for our application, which gives us access to all methods and properties that Express offers to us in order to build on our application. And with this line right here, we are creating a new router object which will be used to define the different routes we will need in order to handle our logic. For example, then we can define routes using methods like router.get, .post, .put, etc. For example, in this section of the code, we define a route handler has an sign up endpoint which is responsible for registering a new user in the system. It uses the post method because it involves sending data to the server, in this case the new user's information. Here the async keyword is used because the operations inside the route handler involve asynchronous actions like database queries and passport hashing. So here we start by extracting the user data sent in the request body, which is the username, passport, and email. And we store it in the new user variable. After that, we check if a user with the same username or email already exists in the database. And how we do this? First, we query the database to find any user that matches the provided username or email, and then this does then, if one or more users are found, it returns true, indicating that a user with the same username or email already exists. And then with this if statement we respond with a 400 status code and an error message if a user with the same username and email exists. So this is how we handle an existing user. And here we have to hash the password, because the password provided by the user should be hashed for security purpose. And for that we use the bcrypt library to hash the password with a salt factor of 10. Hash is a method from the bcrypt library that takes two parameters. The first parameter is the data we want to hash, in this case the password, which is the text that the user has provided during the sign up. And the second parameter is the salt rounds or cost factor, which is 10 in this example. So the salt rounds determine how many times the hashing algorithm will be applied, making the hash more secure but also more precise. Next we create and save the new user. This part is where a new user document is created with the hashed password and saved to the database. New user with spread operator copies all the fields from new user. That is what we get from request.body, and the password field is overwritten with the hashed password. With new user we create a new instance of the user model, which belongs to a new user documents in the MongoDB database. And here with the spread operator we copy all properties of the new user object into a new user instance. And with the save method we save this instance, and we use the await keyword, because by using await the code execution pauses until the save operator is complete. And then after the user is successfully created, a JSON Web Token is generated using a helper function create token and sent back to the client along with the user data. And this is the function that generates a JSON Web Token, which will be used to authenticate users in the application. It just takes a single argument, user ID, which is the unique identifier of the user in the database. This ID will be embedded in the JSON Web Token so that the server can later identify that user based on that token. Then we have the sign-in method from the JSON Web Token library that is used to create a new JSON Web Token. And this is the payload of the JSON Web Token, which is the data embedded within the token. In this case, it's an object. It's an object containing the user's ID. So when the server later receives this token, it can decode it to retrieve the user ID and identify the authenticated user. And this is secret key used to sign the JSON Web Token. So it's secret. It's if someone tries to change the token, it will be invalidated. This secret key is stored securely in another file where we provide a configuration module that exports an object containing settings for JSON Web Token authentication, so it can be imported and used in other files. And this object contains settings related to JSON Web Token authentication. It has two properties, secret and which is the secret key used to sign the web token, the JSON Web Token, and it ensures that the tokens generated by your application are secure. And then expires in, which sets the lifespan of the JSON Web Token. In this case, 24 hours, meaning the token will expire 24 hours after being issued. After expiration, the user will need to authenticate again to get a new token. And here is where we import this configuration, and we use it in this part of the create token function. That then we execute this create token function here in this part of the code that is responsible for sending a response back to the client after a new user has successfully signed up. Here the res object represents the HTTP response that will be sent to the client. The status 201 indicates that a new resource has been successfully created. And then the .json method sends a JSON response to the client. So the data passed inside the JSON method will then be converted into a JSON string and sent as the body of the response. In this case, it's an object containing the token and the user properties. The first property, token, generates a JSON Web Token for the newly created user, and we generate it through the function we already saw before. It takes a unique identifier as an argument, and it generates a JSON Web Token, which is then used for authenticating the user in future requests. The token encapsulates the user's ID and is signed with a secret key to ensure its authenticity. So the generated token is included in this response under the token key. And then the user property just prepare the user information to be sent to the client, and we achieve it through another function called render files, and this function just extracts and returns a subset of the user's data that is to expose publicly. It just ensures that the sensitive information like the hashed password is not included in the response. Alright, so now in the final part of the sign up route, we will handle errors that may occur during the execution of the route. And the way to do it is through the catch block that will handle any errors that might be thrown during the execution of the try block. So if any errors occurs in any part of the code within the try, the control or the flow immediately goes to the catch block. And here is where we send a message or a response back to the client with a 500 status code indicating an internal server error. It is the JSON method that sends this message back to the client. Alright, so after handling user registration in the sign up route, the next logical step in a login system is to authenticate users when they attempt to log in, and that's the login route which is designed to handle this process. So first, remember both the login and sign up routes are implemented as post requests. The post method is designed for sending data to the server to create or update resources. In the case of sign up, you are creating a new user record in the database, and in the case of login, you're sending user credentials to authenticate and generate a token. And this is how we start with this process, storing in this variable the data sent by the client in the login request, which includes the user's email and password. And then through this function designed to retrieve a user from the database based on a specific criteria, we try here to find the user with the provided email. We use await to pause the execution of the function until the find one method operation is complete, and user.findOne is a mongoose method used to search for a single document in the database. Of course, that single document should match the criteria provided. If a match is found, then the user document is returned. And here is where the criteria is located the criteria that we should pass to this function that we define it outside the route. So it's an object being passed as the criteria parameter. An object that has a key value pair where the key is email and the value is the request.body, and we access to the email property. Good, so then we check whether a user exists in the database based on the email provided during the login process. So this variable holds the result of the obtain user function, and then we check if the condition is null or undefined, meaning the no user was found in the provided email. And in this case we console log a message, and then we set an HTTP status code, and then we send a JSON response back to the client with this message. So in summary, this part of the code handles the situation where the email provided by the user does not match any existing user in the database. Next, we verify if the password provided by the user matches the hashed password stored in the database. And we achieve this thanks to a method from the bgrep library called compare. This method is used to compare a plain text password with a hashed password. Alright, that next, after the password verification step, we will check if the password is correct. So correct pass is a Boolean variable that was set in the previous step after comparing the user's plain text password with the hashed password. So if correct pass is true, it means the passwords match and the user has entered the correct password. Otherwise, the login should be rejected. And if the password is correct, we will create a JSON Web Token for the authenticated user. And here is where we invoke again this function that will generate for us this token using the user's unique ID. And then we'll display another console log message. And here we prepare the user data to be sent back to the client by invoking this function render field. That extracts and formats only the necessary fields for the user registered object, omitting sensitive information like the password. And then we send back to the client a JSON object that includes the generated token and the user information, along with a 200 OK status. And if the password is incorrect, first we display this console log and this 401 status with this JSON message indicating that the login attempt failed due to invalid credentials. And finally, This route current user provides a way for the React client to retrieve information about the currently authenticated user. Therefore, when the client sends a GET request to this endpoint, the server use the JSON Web Token authentication to verify the user, and if the user is authenticated, the server responds with the user's details such as email, username, and so on in JSON format. This endpoint is very useful for displaying the current user's profile information in the client application. Note that here we use an authentication middleware that ensures that the request is authenticated using a JSON Web Token, and it is set up using passport.js and configured to use the JSON Web Token strategy. So if the JSON Web Token is valid, the middleware will pass control to the next function in the chain, and the authenticated user's information will be available in the request.user. Otherwise, the request will be denied and React will receive an unauthorized response. And this is a file that is responsible for setting up and exporting a passport strategy for authenticating users using JSON Web Tokens. It uses the passport JSON Web Token library to handle the process of extracting and validating JSON Web Tokens from incoming HTTP requests. Then we import the configuration that contains the information like the JSON Web Token secret. And then we create an instance of the JSON Web Token strategy. It basically extracts JSON Web Tokens from incoming requests, verifies them using a secret key, and checks if the token belongs to a valid user in the database. If the token is valid and the user exists, then the user is authenticated. Otherwise, authentication fails. So this strategy is then used across the application whenever JSON Web Token based authentication is required. So here we have the core structure of our React application that implements user authentication and routing functionality. And basically here is where we handle user authentication flows, including sign up, login, logout functionalities, while managing protected and public routes accordingly. So this main part of the React code is concentrated around user authentication and routing. Here we determine whether the user is logged in, and we render different routes. Here we render different routes based on their authentication status. So the component structure is divided into two main sections, one for logged in users and another for users who still need to log in or sign up. And the use of hooks like useState, as we import here, and useEffect allows the application to manage state and perform side effects. So the primary goal of this application structure is to provide a secure user experience by managing authentication state that keeps track of whether a user is logged in and storing necessary authentication tokens, thanks to this part where we import some relevant functions, then protecting routes, ensuring that certain parts of the application are only accessible to authenticated users, and then ensuring secure API communication. For that we configure Axios to include authentication tokens in HTTP requests automatically. So first we start by importing these React hooks, useState and useEffect. useState is used for managing state in functional components, while with useEffect hooks we will handle side effects like fetching data. Then we import we need from React router DOM that we will use for managing navigation and routing within the app or making requests to the server. That are functions that we define outside this file. And custom components for the navigation bar, sign up page, login page and feed page. And here in this useState hook we manage the user state and loading the current user's data when the component first mount. So first we initialize a variable called user with an initial value of null, and then setUser is the function that can be used to update this user state, and this state will basically hold the information about the currently authenticated user if they are logged in. And then the useState hook with its empty dependency at the end means this effect will only run once. So it will run when the app component is first rendered. And within this hook we have an asynchronous function called loading user that attempts to load the current user's data when the component mounts. First it checks if there is a JSON Web Token stored in local storage by calling this function getToken, function that we import from the helpers that we defined outside. So this code is a utility module that handles token management and sets up Axios interceptors for making authenticated HTTP requests in our application. First we import Axios, and then we define a constant that stores the key under which the token will be saved in the browser's local storage. Remember, local storage is a web API that allows you to store data in the browser local storage. This data persists even when the browser is closed and reopened. And in this case, it will help us after a user logs in, because it can store their authentication token in local storage. And this way, the user remains logged in even after refreshing the page or reopening the browser. So in this sense, the first function that we declared and export here is a function that saves the provided token in local storage. And for that, it uses the setItem method to store the token under the key MERN token. So this function setToken will store the token in the browser's local storage. Then getToken retrieves the stored token from local storage, allowing the app to access it when needed. Then deleteToken just removes the token from local storage. For example, when we want to log out. And then we have this function, init Axios interceptors, that sets up interceptors for Axios, which are functions that run before requests are sent or after responses are received. In this part where we define request in interceptor, before every request is sent, it checks if a token exists through getToken function, and if it does, it adds an authorization header with the token to the request, ensuring that all requests carry the token for authentication. And then after every response is received, it checks the status code, and if the response indicates that the user is unauthorized, the token is deleted and the user is redirected to the login page. So this is a security measure to handle cases where the token might be invalid or expired to our application, ensuring that all API requests are authenticated and handling situation where the user might need to be logged out or due to an expired or invalid token. So all these functions that we defined in this helper file, then we import from our main file. Here we call our function init Axios interceptors. Here is called to set up the Axios interceptors. So when the useFact mounts, it triggers the loading user function, and this function checks if there is a token stored using this getToken function that we explained before, And then if a token is present, it tries to load the user by making a request to the server, which points to the route that we saw in the server here. And if it is successful, then it updates the user state with the returned user data. So this useEffect hook handles the loading of the current user's information when the application is first loaded. First it checks if there is a token. If not, it returns false. And if a token exists, then it sends a GET request to the server. Axios GET is the method that is used to make a GET request to the server, and the server returns the current user's data. So if there is an error, we console log, and here this empty array at the end of the useEffect is the dependencies array. It ensures that this effect runs only once when the component is first mounted. And next, let's move on to the login function, which is an asynchronous function responsible for handling the login process in the client application, and it sends the user's email and password to the server. It sends a post request to the server at the user's login endpoint. The user's email and password in the request body. Await is used to pause the execution of the function until the request is complete and our response is received. And the response from the server is destructor to extract the data object. This data typically contains the authenticated user's information and a token for future authentication. And then we update the component state with the authenticated user information. Set user is, remember, the function provided by the hook useState, and it updates the user state variable. And we update it with the object that we receive from the server. And then we store the authentication token in the client's local storage using the setToken function that we get from here. setToken. So basically this is how we handle the process of login. It sends the user's credential to the server, updates the application state with user's information, and stores the authentication token for future use. And then we have the signup function that is responsible for handling user registration. It sends the user's details to the server, creates a new user account, and then updates the application state with the newly registered user's information. And it also stores the authentication token. And this function takes a single parameter, user, which is an object containing the user's registration details, such as username, email and password. Then we send a post request to this endpoint with the user object as the request body. And then the response from the server is destructor to extract the data of the data object. And then through this function we handle the process of logging the user out of the application. It performs two main tasks: clearing the user's information from the application state, and removing the authentication token from the local storage. By updating the application state to null, we remove the user's information from the application, indicating that no user is currently logged in. And then we call that function that removes the authentication token from the local storage. And now we continue with the part that renders different routes in the application based on the user's authentication status. So the router component wraps the entire routing logic of the application. It enables navigation between different views or pages in the React app. But first we define this line that renders the nav component, which represents the navigation bar of the application. And here we pass the user and logout props. The user prop contains the current user information, while the logout prop is this function that allows the user to log out when they want to do it. And then here we have a conditional operator that determines which set of routes to render based on whether a user is currently logged in. So if user is true, the logged in component is rendered. Otherwise, the logged out routes will be rendered. So this code here defines the main structure of the application by determining which routes should be accessible based on the user's authentication status. If the user is logged in, it will have access to all these routes, and if not, it will be redirected to these routes defined here, except the nav component, which is always displayed regardless of the user status. Let's take a look at our nav component. And this component adapts its content based on whether the user is logged in. It first receives two props, user and logout, and inside these nav elements, which serves as the container for the navigation bar, we have a link component which redirects the user to the home page when you click over it. And then we have a UL element that contains a list that will dynamically display certain routes based on whether the user is logged in. And for that we use a conditional logical AND operator to check if a user is present, and if it is true, the login routes component is rendered. If not, nothing is rendered within the UL. And this logging component is responsible for rendering the routes and links that should be visible when a user is logged in. Inside the component, a single li element contains a logout button with an on-click event handler that is attached to an anchor tag, which calls the logout function when the link is clicked. And this is what triggers the logout process, clearing the user's session. What's the next view? So let's say take a look at this sign up view. So this React component is a sign up form that allows users to register by providing their email, username, and password. And for that we import a useState hook, which will be used to manage state within this component. And here is where we initialize this state variable user with an object containing email, username, and password properties. Initially they are all set to empty strings. And then we declare a function called handle input change, which will update the user state when any of the input fields change. And this function uses the spread operator to copy the current state and then updates the specific field that changed. e.target.name dynamically updates the property based on name on the name attribute of the input field that triggered the event. And then handle submit. This function is triggered when the form is submitted. So this function calls the signup function passed as a prop with the user. This is a function that we receive here as prop. And here in the render output we trigger the handle submit function. And then we encounter a bunch of input fields for users' email, password, and username. All of them triggers the handle input change on the onChange property, which means that when we are in this field, the handle input change function will be called whenever an input field changes. This event handler in React listens for any change in the value of an input field, such as typing into a text box. So when the user types into the input field, the onChange event will be always triggered. And this function then updates the state with the new value for the specific input field that was changed. Similarly, in the login component, it works quite the same. Here we pass this login function and we receive it as prop. We apply it in handle submit feed component which is empty, but here you can build all kinds of apps from an online store to a chat app and much more. Want authentication functionalities.